Welcome to Lesson 1, Learn C Programming on the Raspberry Pi. This is a project I'm making for my grandson, who's 12 years old and trying to learn how to program. I decided to teach him C because it's the basis of most modern languages. And I also decided to have him work on the Raspberry Pi, which is a small credit card sized, very cheap computer, but quite good enough for our purposes. These lessons will be aimed at mostly children who are, let's say, 11, 12, 13, 14 years old, or for that matter could be any adult who has no idea about what a computer is or how to program. So lesson 1, I want to talk a little bit about the Raspberry Pi since we'll be doing all our work on it. I have one here on my desk. This particular Raspberry Pi is the original Raspberry Pi. They call it the Model A. And if you look at it closely, it does have right here, it has a network port. It has 2 USB ports. Over here there's an audio jack. And video. These are GPIO pins here, general purpose input-output pins. They allow you to connect the Pi to different devices like motors and sensors and lights and things like that. This is an interface to some kind of LCD monitor if you wanted one. Here is the HDMI output that you can connect to your television or to a regular PC monitor. This interface here is used for a Raspberry Pi camera, video camera. And then way over on this end we have a micro USB connector used for supplying 5-volt power to the Pi. So this is the original one. I don't think you can buy them anymore. I think they call it the Model A. It's not very powerful, but it's good enough. If you look on the back, you can see over on this side over here is where you put an SD card with the operating system. And I'll show you that in a minute. But let's take a look now at the next generation of the Raspberry Pi, which is this one. This is the Model B Plus. If you look at this one, it has a connector here for the network. It has 4 USB ports. It also has 40 pins instead of 26, and it has the rest of the things. It has an HDMI connector here, has audio out here, video camera if you want it, 5-volt USB connector here so you can power it up. Over here is the interface to an LCD monitor. There's the CPU is right in there. So it's, as you can see, it's a complete computer. Just like a desktop computer or a laptop computer. But it's just small and it's fairly cheap. Here in Canada, you can buy the latest model for about $50. Let's take a look now at the latest model. The latest model is a Model 3. You notice it looks very similar to a model or the second generation Model B Plus. The difference is, of course, is it's faster, it has more RAM, and it's faster than the B Plus. So if you look at them all, here's the Model 3, the Model B Plus, and the original Model A. Okay. So today I'm going to be using the original Model A. It's good enough for our purposes. So I'll do away with these guys. Now with the Model A, the first thing you're going to need is you're going to need an operating system with it. So I have here an operating system on this SD card. This is a 16 gigabyte SanDisk Extreme Pro, so it's fairly expensive, but the reason I'm using it is because it says on there 95 megabytes per second read speed, so it's really fast, and of course the faster the better on these small machines. Okay, so the first thing I did was I downloaded Raspbian, which is the version of Linux for the Raspberry Pi. I downloaded it and I copied it onto this little card. So you're going to have to do that yourself after you buy the Raspberry Pi. So obviously you'll need another computer to download the software and to put it onto this SD card. But once you have the software loaded, then you can put it into this slot here. Okay, so now I have my operating system. So this is basically like the hard disk, your hard drive. Okay, next I'll want to connect a network cable and get some of this stuff out of the way. I want to connect the network cable here to the network port. Okay, so now I have the hard drive, basically the operating system here, I have the network cable here, and finally I need to connect power. This is USB power. This is the same kind of power adapter that you use for your smartphones, for charging your smartphones. Basically it's 5 volts USB. So I plug that in here. Like so. And now I have everything ready. You notice I do not have a monitor connected to the HDMI, nor do I have any keyboard or mouse connected to the USB. Okay, and the reason I don't is because I don't need those. This is configured as what they call a headless computer. Headless meaning there's no monitor, there's no keyboard, there's no mouse. So you're probably wondering, how do I use it? Well, I use it by connecting through this network cable using a terminal emulator of some kind, and I'll show you how to do that. The first thing I want to do is power on this Raspberry Pi. So I'll hit the power switch and you can see the lights come on. And once it starts booting up, you'll see like the green light comes on, the red light comes on. If you get a solid red light, then there's a problem. So you should just be patient and wait till this thing powers up. Now while it's doing that, I'm going to bring up a terminal here. And I believe it's on port or with IP address 208. Let me just check that. So you can see here, I do have on my home network, I have the Raspberry Pi connected on with IP address 208, and this is actually the MAC address of the Raspberry Pi. So what I'm going to do is I'm going to use SSH Secure Shell to connect to the Raspberry Pi. Now the username on the Pi is Pi. The username is Pi, so I'm going to connect to Pi at 192.168.2.208. And hopefully I'll be able to make a connection. And ask for the password. And the default password for Raspbian is Raspberry. Raspberry. So I connect up to it. Okay, and if I do an ls, this is what comes on the Pi, well, except for this little test program I wrote the other day. But all these other directories in blue are what comes default with the Raspbian operating system for the Pi. So now I've connected to the Pi, I'm on the Pi, and what I'd like to do now is to write my first C program. So the program I use for that, or to write code, is Genie. And what I do is I run it in the background like this with the ampersand. Okay, so let's wait for that to start up. And there it is. So you can see I already have a C program here. You notice it has only 5 lines to it. Number sign include standard io.h. Second line is int main. Third line is printf, hello world. Fourth line is return 0. And the fifth line is just a brace. So that brace has to connect with this brace here. So basically every C program has to have a main function, which is where the program starts. And the main function is defined by these braces. So that's the body of the main function. Okay. So using this Genie development tool, I can then go and, for example, I can build my application. Which means to basically compile it. And so down here it says they gave the command gcc -wall -o a1 a1.c, and it's in the directory home Pi. And it says compilation finished successfully, and now I'm able to actually run the program because it did compile correctly. I can now say execute. And if I execute, I get another window pops up here, and this is the output of the program, hello world. And then it says press return to continue. So I just press return, and that's it. So if I wanted to make a change now to the hello world program, I could say, for example, I could type in hello my world, and then I'd have to, of course, I'd have to go to build again, and now it's doing it, it's compiling again. It says compilation finished, and now I could go and say execute, and now it executes, and over here I have the output, hello my world. Okay, so let's close this development window here like this, and if we go back to our directory, you can see that A1 is there. You can see the code, and you can also see the executable. A1 is the executable. So this file here is called source code, and this file here is called executable code. The executable code is binary. You can't well, you're not really supposed to look at it with an editor of any kind. It's in binary code, but the source code is basically in human form, so you can actually see the source code. Okay, so that's a little bit about the Pi and C. Now let's take a look a little bit more in depth here. I have a web browser. Just show you over here, move this window a bit. It says, the Raspberry Pi is a series of small single board computers developed in the United Kingdom by the Raspberry Pi Foundation to promote the teaching of basic computer science in schools and in developing countries. So this is basically to show you the Raspberry Pi Model 3. This is the latest version. Okay, now let's take a look at let's do a search here. C language. C programming language is a general purpose computer programming language supporting structured programming. Okay. Some history here says C was originally developed by Dennis Ritchie between 1969 and 1973. So you can see it's quite an old language, but you have to remember that it has a lot of derivatives. For example, C++ is built on C. C# is more or less built on C. Java is kind of a C type derivative. So there's a lot of modern programming language all take their references from C. So the idea of learning C first is quite simple. Is if you learn C first, then learning other languages will be easier, because it's kind of the foundational language. Okay. Okay, so let's go back now. I'll close this window. Let's go back to here. When I'm done programming, I can then exit my terminal. Well, just before I do that, I want to shut down the Raspberry Pi. So I can say sudo halt. And this will shut down the Raspberry Pi. You might see some of the lights flash once I do this. Okay. And you notice my connection to it is gone. I'm now back on the PC in my basement. And you can see the lights flashing on the Pi because it's shutting down. Right here. And finally, once it gets to like a solid red light, the Pi is now shut down. Okay. So it's now safe to turn the power off. So I can turn the power off. Okay. So let's just go through that process once again. I'll first power up the Pi by turning on the 5-volt USB power, and we'll wait for the Pi to boot up. So you can see it's booting up. If I try to connect to it now, I may not be able to, because it's not ready yet to accept connections. The boot process is not finished. But given a little bit of time, it should eventually connect. There we go. Raspberry. I hope I typed that in correctly. Yes, I did. Now what I'm going to do is I'm going to make a directory here called lessons. And then I'm also going to delete this A1 and A1.c. I'll delete these two programs. So now I just have a bunch of directories. So I'll change directory to lessons, and I'll make lesson -01. So inside lessons I have a directory called lessons1. So I'll go to that directory, lesson01, and I'll start up Genie. Again, I'll run it in the background. Remember, I'm running now on the original Raspberry Pi Model A, so running these applications is probably going to be a little bit slow. You notice it says failed to load one or more files because I deleted those original files, but I'll make another one now. Insert. I'll start off with the main function, and in the main function I'll declare an integer, say x, and I'll initialize it to 3. Oops. And then I'll say printf x is so I'm going to now just print out the value of x. And now what I want to do is I want to save this program because right now it's untitled. So I'll save it, file, and I'll say save as, and I'll just call this, I'll go to the folder, lesson1 folder, and I'll just call this example1.c. Okay, so now I have it saved right here. It's in home, Pi, lessons, lesson01, and it's example1.c saved. So what I'll do now is I'll build it. So it will compile with the GCC command. Compilation finished successfully, and now I can actually execute it like this. And lo and behold, there it is. The value of x is 3. Press return to continue. Now, of course, I don't have to use this integrated development environment, Genie, to do my compilations. I could also do it. Let's clear the screen here. Let me just remove the executable, and I will just compile manually now. GCC ex1.c minus oex1. I can just compile it like this. So now you can see I have the executable there, and I can run the executable like this by just running it and have it a value of x is 3, so you can see it actually works. Okay. Again, I'm finished with my lessons now, so I want to shut down the Pi, sudo halt, and again these red lights are going to start flashing over here. Green lights, yellow lights. Finally, once it gets down to a single red light, it means it's finally stopped, and I can turn the power off. So I'll turn the power off on the Pi, and what I can do is now I can unplug everything here. I can unplug the network, I can unplug the power that way, and I can even, if I wanted to, I could take out the SD card. So my program and the operating system are stored on here. That example1 ex1.c and ex1, the executable, are both stored on here, and I could put this into another Pi, and I could continue on. So if this Pi here broke, I could just maybe buy another one. Okay, so that's the idea behind running or compiling C programs on the Pi, using the Pi, and for all the rest of the lessons, this is exactly what we'll be doing. The only difference is that our C code will get more and more complex as we go along. In the future, I plan to actually connect different components or devices onto the general purpose input-output pins, and write a C program that actually uses those devices. For example, a C program that can drive a motor, make the motor spin slow, make the motor spin fast, make the motor go forwards, make the motor go backwards, and so on. So that'll be for later on lessons once we learn a little bit more about C coding. Well, that's all we have for now. Stay tuned for lesson number 2. And thanks for watching.